Hi everyone. So in this particular video discussion, we are going to tackle about energy and energy balance. So this is actually one of the chapters included in the final term for both nutrition fundamentals and nutritional biochemistry. Okay, so but before we proceed to the formal discussion, so energy is actually one of the things that we are going to discuss routinely throughout your course in the BSND because foods give us energy. Okay, so that's why in this particular video discussion, you will be introduced to the concept of energy in the nutritional context. Okay. Of course, you know na already no that energy is the ability to do work, and energy comes in many forms. Okay, so um, we have been tackling this already since elementary. Okay, so yeah, if you can recall, no, we have this list of forms of energy. Okay, although this is limited, of course, there are hundreds of forms of energy, no, but these are the most common examples of forms of energy. So we have solar, chemical, mechanical, thermal, electrical, sound, light, gravitational, chromodynamic. And you recall guys that energy can be classified generally into two. We have the potential energy and then the kinetic energy. And you know that potential energy is the energy at rest. Okay, and then kinetic energy is the opposite of that. It's the energy in motion. Okay, so these examples, no, some of these are kinetic, some of these are potential. Okay, say for example we have your chemical energy, so this is actually potential, no, but we can actually convert that potential energy into kinetic energy and vice versa, and that's what we are going to discuss in the next slides. Okay, and we are going to relate that with nutrition. So um okay, so as what I have discussed, okay, energy is the capacity to cause change, or is the ability to do work, because that's like the most classic definition of energy. Okay, so living is actually a work. Okay, it's actually a great work. So in order to sustain living, or in order to make living possible, of course energy is required, because energy is the ability to do work. So in order for the living to sustain, kinahanglan nga na ay energy. Okay, so without energy, life would cease to exist. Okay, because the very definition of life, it requires the input of energy. And guess what? In order for the living things to acquire energy, they have to get that from the foods that they eat. At least in higher organisms, no, like multicellular organisms like us. Okay, so the only way for us to get energy is we eat. Okay, of course, there are other organisms that don't need that, because they can directly utilize the energy from sunlight. Okay, so they really don't need to physically eat. They just have to be exposed to sunlight in order to make their food. And that is the process of photosynthesis, as you know. Okay, so an organism requires energy and nutrient input, and that is very true to us humans. So energy is required in order to build molecules into larger macromolecules like proteins. Okay, so katong mga macronutrients na to, no? And to turn those macromolecules into organelles and cells, which then turn into tissues, organs, and organ systems, and finally into an organism. So the organization of life itself needs the input of energy and nutrient. So proper nutrition provides the necessary nutrients to make the energy that supports life processes. So your body builds new macromolecules from the nutrients in foods. Okay, so the very thing that composes you as an organism, as a human organism, it actually comes the carbon, the nitrogen, the oxygen, the hydrogen, all of those come from the foods that we eat. Okay, so that's why there is a saying that goes like this, no? Um, you are what you eat. And that's chemically true. Yeah. Kay nga no, yeah, so katong akong ingon nga, um, we build our tissues, our organs from the atoms that we get from the foods. Okay, and actually, during the process of breaking down those compounds that we get from foods, energy is released. So that energy is trapped as ATP, and then um, that ATP can now give us energy. So, therefore, both matter and energy, we get that from the foods that we eat. So that's why foods are essential. That's why foods are very important for us to live. It's because it's the only way for us humans to get matter and energy. Okay? So, yeah, you are going to fully realize that in the next slide. So, a concept that is very important to our discussion now is the laws of thermodynamics, specifically the first and second laws of thermodynamics. Yeah. Recall, guys, that first law of thermodynamics is energy cannot be created nor destroyed. It can only be transformed from one form to another. Okay, so this states the law of conservation of energy. So the energy of the whole universe is actually conserved. Okay, so the energy that we utilize now came from the very beginning. It has already been existing since the Big Bang. Okay, so yeah, yeah, so we just get that energy, no, and transform that to one form to another. Okay, so we cannot create it nor we cannot destroy it. Okay, so they are just transformed. Energy is just transformed from one form to another. So what is the biological application of that? Okay, so as what I have already maybe discussed to you kato sa carbohydrates nga topic, no. So how is energy from the sun, which is actually the one that gives all energy to all living things here on earth. So ang source of energy nato kay gikan sa sun. Okay, tanan nga organisms diri sa earth kay ang ilang energy gikan sa energy. Ang ilang energy gikan sa sun. Okay? So yeah, how does that operate, no? How does that concept operate? um First is of course the sun gives off energy in the form of radiant energy, no, and that energy is captured by the producers. So kaning producers nato mao ni ang plants nato, no. Okay, they have specialized structures in their cells called chloroplasts, and those chloroplasts are able to do photosynthesis. So the photosynthesis, in the simplest sense, is it is just the process in order to convert radiant energy in the form of sunlight, para ma-convert na siya, no, kana nga type of energy into chemical energy, and that chemical energy is stored primarily in the form of starch, which is a carbohydrate. Okay, although plants can also trap that radiant energy from sun in protein forms or in um, fat forms. So that's why, for example, kanang coconut tree, um, they store the energy that they get from sunlight in the form of fat sa coconut, no, sa sulod sa uh, coconut fruit. Okay, but primarily, guys, they store it in the form of starch because that's the what's this, the plant form of carbohydrate storage. Okay, so yeah, unsaon lugar na nila dayon kanang starch nga na-produce nila or proteins o fats nga na-produce nila. Mao na ilang source of food, okay? Mao na ilang source of energy food. And then ang excess ana gina-store nila as starch. Okay. And that plants are of course unsa eaten by the herbivores, okay, or any other living things that depend on plants as their source of nourishment. So, yeah, katong mga plant matter and then ang energy nga na-trap dito sa sulod no sa chemical bonds. Okay, sa chemical bonds na siya actually matrap no. So, yeah, they are eaten and then they are those energy no are released to be used for the consumer. Okay? So the energy it just comes up to the unsay tawag ana food web, okay? Hangtod nga makaabot siya sa humans as one of the final consumers, okay? In the food pyramid. Sa ba tawag ana sa kuan? It's food web, okay? Food web. So, yeah. So the process of photosynthesis is this, okay? So energy from the sunlight, and then aerobic respiration is actually the opposite of photosynthesis. So yeah, remember that in photosynthesis na ay ma-produce nga glucose, okay? And kana siya nga glucose they can polymerize into starch because you know that starch is composed of just glucose, okay? So aerobic respiration, this is the process that we do as the consumers, okay? Producers, they do photosynthesis, so they convert simpler compounds like carbon dioxide and water, then na ay energy input from sunlight, then maka-form dayon sila ani. Okay? So asa ni gikan kining C6H12O6, this is just glucose. So you might wonder no, asa ni gikan ang mga carbon atoms? Actually gikan ra na sa carbon dioxide. So they actually get carbon dioxide from the air. Okay? So ga-harvest sila og carbon dioxide from thin air. Then they combine 6 carbon dioxide para maka-form og sucrose because glucose, because glucose has 6 carbon atoms. Then aside from that, aside nga nag-combine sila carbon dioxide nga 6 ka buok, nag-combine pud sila og 6 water molecules. Yeah, in order to form this. Okay? So 6H2, so that's 12 hydrogen atoms and 6 oxygen atoms. So combine that two and then you can form a glucose molecule. But this cannot be formed without an energy input. So kanang energy itrap na sa bond nga present sa glucose molecule. Okay. So plus the byproduct is 6 oxygen atoms because remember natay mga oxygen atoms diri sa carbon dioxide. So that's why I don't know if you have if you can recall, but you must really recall this one kay mao ni usually atong gina-discuss sa since elementary pa no nga the plants they require carbon dioxide in order to live because that carbon dioxide, they need that carbon dioxide para maka-produce og sugar, para maka-produce og glucose. Okay? Para makahimo sila og photosynthesis. Then as a consequence of that, they release oxygen. So aside from sugar, ga-release pud sila og oxygen and then they release that out of their tissue. They release that to the environment or to the air. And that oxygen is, remember, mao na siyang kinahanglan nato. Okay? And then, since this is the one that we do, kaning aerobic respiration, the final product is actually carbon dioxide. So, kaning carbon dioxide ma-release sad out of our body and then, kibali, mauna sad na ang kinahanglan sa mga producers. para ma-sustain nila ang photosynthesis. So it's just actually um, gahatag sila sa atong oxygen, then gahatag pud ta og carbon dioxide for them. Okay, so that's actually the cycle, no, one of the cycles of life. Okay, so they produce oxygen for us, and in return we produce carbon dioxide for them. Okay, so what do we do with this sugar? Okay, it's because, guys, if we eat plants, yeah, if we eat, for example, vegetables, it's not in the form of sugar, but it's actually in the form of complex carbohydrates. Okay, so since we can get pila 16 calories per exchange of um, vegetables, so usually ang naa diha, no, is in the form of very minimal lang ang starch diha, then in the form of cellulose, and then um, due to the action of microbes in our large intestines, they can actually break that down in a certain extent. Then we can actually absorb the byproducts of fiber digestion in the large intestines due to microbial action. So that's what we get from the vegetables. But if we eat fruits, so they are usually in the form of sugar because daghan og sugar sa fruits, di ba? If we eat cereals like rice, so we know that ang naa sa rice and in any other cereals is starch. Okay, so it's not in the form of glucose, but it's actually in the form of starch. Okay, so unsaon nato so yeah, so ang rice, kanang rice grain, okay, kanang kanon nato, no, it's in the starch form. So unsaon nato para ma-convert siya into glucose. So that's why naatay ginatawag nga digestion. So after we eat rice, that is subjected na to digestion, then makaproduce sa dayon og monosaccharides like glucose. Okay? So once naka-produce na tag or na-digest na ang starch into sugar molecules, then we absorb it and then i-deliver sa mga cells that require energy. Then pag abot dito sa cell, si glucose is phosphorylated para mahimong G6P, and that is the first product of glycolysis, or that's the first substrate needed for glycolysis to continue. So kanang glycolysis is, para ma-breakdown, no, so i-breakdown nato ang glucose into smaller molecules, taman nga makaproduce tag carbon dioxide and an energy output. Okay, so through the process of aerobic respiration, because the first process of aerobic respiration is glycolysis. So yeah, then the second is Krebs cycle. So actually sa Krebs cycle, ta maka-produce og 6 na carbon dioxides from the glucose molecule. Then ang water is actually ma-produce nato sa electron transport chain. Okay, and yeah, through because of the breakdown of this sugar molecule, natay ma-produce dayon nga energy that is trapped into the ATP. Okay, so yeah, so diba gibali lang ang photosynthesis sa aerobic respiration. So that is actually how energy is flowed down to the radiant energy, down to the chemical energy. That's also how living things transform energy. Okay, so you might notice, no, gikan siya sa light energy, okay, or sa radiant energy, then gi-transform siya into chemical energy. And then after eating food compounds, then through our body, no, through the functions of the different organs, specifically the muscles, our muscles can convert chemical energy in the form of ATP into mechanical energy So mechanical work is actually done when we move around, when we walk, when we jog, when we run. So that's actually mechanical energy that is being released. And aside from chemical energy that is trapped in the ATP, okay, so ang energy nga actually dili tanan nga energy nga gikan sa sa ginakaon nato, no, kay i-trap siya ni ATP because some of the energy is lost as heat. So you can observe that specifically when you run, 'di ba? Naada yung heat nga ma-form. That's actually the heat that is not trapped by the ATP. So it is lost in the form of heat, and it's actually a form of entropy. It's a form of disorder. That's actually an unusable form of energy. So that's why some scientists believe that the process of aerobic respiration is inefficient because not all energy that we can get from foods is actually used. Some of them is lost as heat. Okay? So, you see, nakita ni mang transformation sa energy from radiant energy then to chemical energy and then to mechanical energy when we move around, when we do our physical activity. Then yeah, pwede pa na siya i-convert, no, into other things, like for example when we clap. Okay, so that's mechanical energy and then it is rapidly converted to sound energy. Okay, yeah, so yeah, that's an example of the first law of thermodynamics. So energy is not created, actually it's just transformed from one form to another. The second law of thermodynamics, it's related with the entropy nga term, no. So entropy is disorder. So every energy transfer or transformation increases the entropy of the universe. So during every energy transfer or transformation, some energy is unusable and is often lost as heat. So katong akong ingon nga after aerobic respiration, after the energy is harvested from the chemical bonds of glucose as well as from fats and proteins, not all of those energy are trapped in the ATP because the form of energy that is trapped in the ATP is actually the one that we can use. Okay? The one that we cannot use is those energy that is lost as heat. So, di ba katong ingon nako nga, yeah. Okay, so this is actually a perfect example of the two laws of thermodynamics applied in living organisms. So the first law of thermodynamics is this is na yung mga chemical energy diri. Okay? Then yeah, gikaon siya sa brown bear, no. And then unsa may mga bonds diri, unsa may mga molecules diri nga ga-store og energy. Isda man siya, so wala kaayoy glycogen, although na ay mga glycogen. Glycogen is a form of carbohydrate, but actually the main molecule that stores the energy in fish is fat. Okay, unsaturated fats. So fats are very concentrated when it comes to the energy content, no. That's 9 calories per gram. So that's a very big supply of energy stored in the chemical bonds of fats. So through the process of digestion, so kauno na niya, then ma-digest na siya, ma-digest ang mga fats as well as proteins. Yeah, proteins can also give us energy. Yeah, recall that 4 calories per gram ang energy density sa proteins, so just like your carbohydrates. So after digestion, then i-absorb na siya sa bear. And then katong mga na-absorb nga mga molecules, they are then subjected to aerobic respiration. Then ang i-release, then ang products na dayon sa aerobic respiration is carbon dioxide and water. And then i-release na siya sa environment. Then kaning carbon dioxide mao ni ang gamito na sad sa mga plants para makaproduce og another starch, og another proteins and fats para ma-sustain ang life, para ma-sustain pud ang life sa mga consumers, no, like us, like this bear. Okay, but not all of the energy is actually used by the bear because some of the energy is lost as heat. Okay, so for example, magdagandagan lugar na siya, so na ma-produce nga heat ana, just like us, di ba? If we run, yeah, naatay mapansin man aninyo Okay, we natay ma-feel nga heat. So that's actually the heat that comes from the food that we eat. That is because of how the body metabolizes the foods that we eat. Okay? Then nganong makadagan man ng bear tungod tungod sa energy nga gikan sa food na iyang gikaon. Okay? Then kanamang good energy nga gikan sa food niya gikaon niya i-convert na or bali i-trap na siya by the ATP. And ATP is the energy currency of all living things. Okay, so kibali ang energy gikan sa food then ibalhin na siya sa ATP. So kanang ATP mo nang ginagamit sa mga living organisms. That is now our supply of energy. Okay? But again, some of it are not captured by the ATP. Instead, they are released as heat. So ang heat is actually the entropy because that's the one that we cannot use. Yeah, this is a useless type of energy. So that's why grabe ang contribution nato sa entropy into the universe because this is released into the universe. Yeah. So as time goes by, the level of disorder, the level of entropy is becoming high in the environment. Okay, so that's the second law of thermodynamics. Okay. So you would not expect that physics can be applied in nutrition. Yeah, in nutrition, guys, we tackle not just biology and chemistry but also physics because energy itself is mauna ang routine nga, mauna ang main subject sa physics. Okay, it's just that ang energy nga ginatakal nato sa nutrition is in the form of chemical energy that is stored in our foods that we eat. Okay, so yeah, that's it. Okay, so that's quite a very lengthy introduction, but I hope I have what's this, instill in your mind the relation of nutrition with other concepts that you might have encountered during your discussions of physics as well as sa chemistry and other subjects. Okay. So sa kaninga mga energy, ang ato gyud nga main concern ani is chemical energy because ang chemical kay ang kanang energy nga makuha nato sa food is chemical energy because it's stored in the bonds of carbohydrates, proteins, and fats. Okay? So from here, atoan nang i-discuss unsaon nato pag-use, unsaon nato pag-harvest sa chemical energy nga gikan sa food. Okay? Para ma-apply siya in nutrition. Okay, so mauna na siya itong i-discuss from this slide. Okay. So measures of food energy. So we have direct, indirect calorimetry, and the use of formulae or different formulae, no? So natay para ma-measure na to ang amount of energy nga na-store sa atong food, historically a bump calorimeter is used. Okay, so mao nang setup sa bump calorimeter, no, then ibutang diri ang food, then na mga electrical wires. Okay, so actually heat is introduced here, then na ay chamber that is the source of oxygen para combustion is possible. Kinahanglan ba og oxygen para ma-combust ang food. So the amount of heat generated from this apparatus is measured, and it would be equivalent to the amount of energy stored. Okay, so actually kaning bump calorimeter is to completely combust the food so that the heat that comes from this is measured as the amount of energy that is trapped in this food. And repeated experiments with this apparatus consistently derive this amounts of energy. Meat, mao ni siyang representative sa proteins. Butter, mao ni ang ga-represent sa fat. Starch, mao ni ang ga-represent sa carbohydrates. And ethanol is alcohol. Okay, so meat is actually that's 5.35 ang iyang heat, ang amount of heat after it is subjected to bomb calorimeter. Then the availability is 92%, so it is adjusted, so the net is 4. Okay, butter 95% available, so the loss is 0, so that's why the net is 9. Then starch 4 and ethanol is 7. So actually kani very familiar, di ba? This is the energy density of carbohydrates, fats, proteins, as well as alcohol. So recall that protein has 4 calories per gram, fat has 9 calories per gram, starch or carbohydrates has 4 calories per gram, and alcohol is 7 calories per gram. Okay? So, you might wonder, no, asa na gikuha kanang 449 4 calories nga 4 calories per gram nga carbohydrates, 4 calories per gram nga proteins, and 9 calories per gram nga fat. Gikan na siya sa experiments using bomb calorimeter. Okay? And I don't know if I have already introduced this one, but alcohol also gives us energy. So that's 7 calories per gram. So it's also very high, no? Just like your fat. So that's why kanang inyong mga shot makahatag po na og dakong energy sa inyo. So that's why it can also contribute to the excessive accumulation of calories in the body in the form of fat. Okay, so we can also measure the amount of energy through indirect calorimetry. So these are the methods of indirect calorimetry: oxycalorimeter, respiratory calorimeter, and whole room calorimeter. So the room calorimeter or respiratory chamber, so the individual or the patient, because usually this is used in the metabolic rooms of big hospitals. I don't know if we have a respiratory chamber here in the Philippines, but I think nasa St. Luke's. So it looks like a normal room, pero di ay mga naka-attach diha that would sense the amount of carbon dioxide. Okay? So actually guys, ang indirect calorimetry is we measure the amount of carbon dioxide in the air, and then kung unsa tong ma-derive nga amount, that is correlated to the amount of energy that is expended and the amount of energy that is present in the food. Although kani siya ang energy expenditure sa tao ang gina-measure, but there are respiratory chambers that are designed for the measurement of carbon dioxide released by food items. Okay, I don't know if na ako picture ani, but yeah, that is also one of the ways to measure the amount of energy in our food. So yeah, so kani direct nganong direct man siya kay directly gina-measure man nato ang amount of energy, but kani we just measure the amount of carbon dioxide that is released. And then since we know that carbon dioxide is released in the process of aerobic respiration, so that means energy is also released. So therefore, although it's not directly measured the amount of energy, but we know that kung naay carbon dioxide ma-release, naa sad energy nga ma-release. So the amount of carbon dioxide is correlated to the amount of energy. And that's how we measure the amount of energy in the food indirectly. Okay. Out of these apparatuses pud naapod natay makuha nga RQ. So RQ is respiratory quotient. So this is actually the amount of carbon dioxide produced in relation to the amount of oxygen consumed. Okay, di ba? recall that katong akong ingon about sa aerobic respiration no nga input na to oxygen, okay, then ang output is carbon dioxide. So that means if you have an RQ of 1, so since katong mauman to ang definition sa respiratory quotient, that is the ratio of carbon dioxide to oxygen. So that means 1 carbon dioxide is produced from 1 oxygen. Okay? Kaning protein, 0.81 carbon dioxide is released from 1 oxygen. Then, ang fat has actually the smallest RQ because fat would only release 0.7 carbon dioxide from 1 oxygen. Okay? So, that is the RQ. And this is very important, specifically when we deal with patients that have difficulty breathing, because we would actually increase the macronutrient that can only give us smallest amount of carbon dioxide possible in every oxygen consumed, and that is fat. So para mas dili maglisod og ginhawa ang patient, dapat gamay ang carbon dioxide nga ma-produce per oxygen, and that is actually fat. So that's why fat is increased in patients nga na ay difficulty breathing, like complicated COVID-19 patients. Okay? Yeah. So this is the energy density. Okay, recall that carbohydrates has 4 calories per gram, protein has 4 calories per gram, and fat has 9 calories per gram. Okay. So, another way to measure the food energy is mag-compute ta using known energy densities. So, we know that fat has 9 calories per gram, proteins 4, carbohydrates 4, and alcohol has 7 calories per gram. And actually guys, naapay other dietary compounds, so mga compounds na makita nato sa atong diet nga gahatag pud og energy sa atoa. But nganong wala sila gina-appeal sa counting? Kay usually they are either actually found in very minute amounts sa atong foods, such as kaning organic acids. Okay, kaning mga organic acids, lactic acid, malic acid, fumaric acid, mao na sila ang katong intermediate sa Krebs cycle. So katong mga substrates sa Krebs cycles, they are actually organic acids. Yeah. And then ang ilang content sa food is very very minute. So that's why they are not counted na kung mag-calorie counting ta. Okay, so polyols, sugar alcohols like atong sorbitol, maltitol, xylitol, they have 2.4 calories per gram. Fiber has only 2 calories per gram. Recall no nga this must be 0 kay di man nato ma-digest. Yes, di nato ma-digest using human enzymes, but fiber is actually digested in the large intestines where gut bacteria are located, and they have the necessary enzymes to digest fiber. But nganong 2 lang, it's because half of it is actually used for their own needs, and half of it is donated to the host. So kita man ang host atong mga bacteria. So at least natay makuha nga 2 calories per gram out of the digestion of fiber of the bacteria in our large intestines. All other nutrients in food are non-caloric and are thus not counted. So, nabaway nakit-an nga cholesterol diri wala. So, cholesterol is non-caloric. Yes, you might be tempted to relate cholesterol to fat, no? But I told you in the fat discussion that cholesterol is not fat. But it's a lipid, and you know that naay difference ang lipid and fat. So, yeah, cholesterol is not is not caloric, is non-caloric. Water, it's the only macronutrient that can give us no cholesterol. So asad siya what sad siya energy. So unsa pa, our micronutrients, vitamins and minerals, yeah, they are also non-caloric. Okay, so yeah, So when we do calorie counting, this is what we use. Kaning 9, 4, 4. And if it's a drinking alcohol, then we use 7 calories per gram. Okay. So how do we use this energy? Okay. So actually katong aerobic respiration, that is the central metabolic pathway. So when you say central, mauna siyang pinaka kumbaga naa siya sa tunga no sa metabolic map kay it's the metabolic pathway that is concerned with harvesting energy. So para ma-harvest nato ang chemical energy nga naa sa food, mauna siya ang gina-employ nga mga biochemical reactions sa mga cells sa atong lawas para lugar makuha nato ang energy nga ma-store diri sa foods. Okay? So, nganong makakuan man ta, nganong makamove man ta, nganong makalakaw man ta, nganong makathink man ta, nganong actually basically tanan nga tong ginahimo as a human being kinahanglan nag-energy input. And asa man ta makakuha energy sa foods, okay? Daw be sir, if wala tay kaon, asa ta magkuha energy? Okay. So that's the purpose na of the stores in our so maka-store man tag carbohydrate in the form of glycogen. So mao na atong una gamiton. So for example, nag-fasting ta or wala ta nagkaon. So temporarily magkuha sa tag energy gikan dito sa glycogen. Okay, so kanang glycogen is converted to glucose in the process called glycogenolysis, which we will discuss sa metabolism nga part for ND51 students only, because I would also give this video discussion to my basic nutrition or to my nutrition fundamental students. Yeah. So okay. So inana siya no. So through the process of metabolism. Okay, so the process of metabolism includes the harvest of energy from the foods that we eat. So, actually, the first kanang stage of metabolism is digestion. So, we break down big molecules into just their building blocks, and then we absorb them, and then pwede na dayon sila is subject to a series of enzymatic or biochemical reactions leading to harvest of energy. Okay, so the chemical energy from the food is just converted to another form, but same ra gyapon nga for nga type of energy, chemical ra gyapon. Okay, so in the form of ATP, that's our energy currency. But some of the energy is released as heat. So mo ni ang entropy, mo ni ang dili ma use no. Makuha na siya mo mapadulong ra na siya sa air, padulong ra na siya sa atmosphere kanang heat. Okay? And it's not used because it's a form of entropy. Chemical waste, so mao ni ang mga wastes nato from metabolism or from aerobic respiration, carbon dioxide, water, but it's not actually really a waste because carbon dioxide is used by the plants to form another carbohydrates, proteins, and fats. Okay, so it's not actually technically a waste kay mao nang ginagamit na sad. So i-recycle na sad ni siya kaning carbon dioxide para mahimong another sets of kanang kuan macronutrients. So the same carbon dioxide kaning mga atoms kan asa carbon dioxide ikuan na sad na himuon na sad na nga sugar by the kanang plant, so i-absorb na sad na nila. Mao lagi na karon di ba na atoy kanang bag-o karon nga nahimo nga it's a factory that converts carbon dioxide from thin air, then makaproduce na dayon og kanang flour. Okay, yes, inana na ang karon no na tay technological capacity to do that. So di na magkinahanglan og plants. Pero it's a very expensive procedure pa at its infancy pa siya no kana siya nga technology. So it's not widely used pa. studies pa are being conducted para mahimo siyang mas less expensive. Yeah, directly gyud magkuha gyud sila carbon dioxide so it's a machine that harvests carbon dioxide directly from the air, and then kana siya nga machine no, it converts katong mga carbon dioxide to proteins, carbohydrates, and fats. Then ang ma-produce is like a flour, mura siyag flour. Okay, then mauna dayon ang basis sa para mahimog food products. Yeah. But the more natural machines to do that is the plants. Okay? So that's why plants are very important because mauna tong source of food. Okay. So ATP is adenosine triphosphate. So mao ni siya. Triphosphate, nganong triphosphate kay tulo nga phosphate. 1 2 3. Then it's combined with a ribose molecule and a nitrogenous base which is called adenine. Okay? So when energy is required, guys, so anabolic reactions store energy released from a catabolic reaction, and catabolic reactions release energy to be used in an anabolic reaction. I will discuss this in the introduction to metabolism, no, how do we produce ATP, and unsa pag-produce og ADP. Basically, guys, no, para maka-produce tag ATP, kinahanglan sa ADP then a phosphate group. So, a phosphate group is combined with ADP. Kaya ADP is duha ra man ang phosphate ani. So, if naay phosphate group nga mag-attach to this, so maka-form tag ATP. But in order to do that, kinahanglan og energy input. Kay para ibutang tong energy sa ikatulo nga phosphate group nga maka-form dayon og the third bond. Then kana siya nga bond no, kay mao na ang diha nato gina-harvest ang energy. Yeah. So ahamanin nato makuha, guys, ang ADP plus phosphate. Nato makuha ang energy nga required para mag-combine ng isa ka phosphate with ADP. Mao na siya ang energy nga gikan sa foods. Okay, sa mga chemical bonds sa carbohydrates, proteins, and fats. Delivered by actually the FADH2 and DADH. Okay, and this is actually accomplished in the electron transport chain, which I will discuss sa metabolism na nga part. Okay, sa katong mga nutrition fundamentals na kung student, so we will tackle that when you reach nutritional biochemistry. Okay, so so mauna siyang energy nga gikan sa atong food. So unsaon nato pag-expand, unsaon nato gamit ana nga energy. So naatay ginatawag nga energy expenditure. Okay? So kibali ang energy nga ginagamit nato has three components. Energy nga gina-spend in our physical activity, that's PA, and energy that is spent in the digestion and absorption of our food. So that's thermic effect of foods or thermogenic effect of foods. And the one that composes the largest in our energy expenditure is our basal metabolism. Okay? Sige, so let's first discuss kaning basal metabolism. Unsa ni siya? Okay. So basal metabolism, so mao na ang energy nga atong ginagamit in the maintenance of basal metabolic processes or involuntary activities in the body. These are the following: respiration, circulation, gastrointestinal contractions, maintenance of muscle tonus, body temperature, functionalities of individual organs and tissues. So actually, mga involuntary activities in the body, like unsa man ang mga involuntary activities sa atong lawas. Breathing, the breathing process, we cannot actually control the breathing process. So we just breathe, okay, without even consciously controlling it because it's an involuntary action. Beating of the heart, mapugnan ba nato ang atong pagbeat sa atong heart? Di ba dili? Okay? Because it's an involuntary activity. And did you ever wonder unsa nga energy atong ginagamit ana? That's actually the energy that is expended for basal metabolism. Okay? And imagine your heart is working every pila, every second. Yes. For the rest of your life. Okay? So imagine pila ang energy nga need ana. So that's why uh, it's no wonder nga ang metabolic rate or the basal metabolism composes the largest of our energy expenditure. Okay? Other than that, respiration, circulation, okay, pag-contract, peristalsis, yeah, it also needs energy. And ma-maintain nato tong body temperature, no, it's actually basal metabolism. Okay. So, wala na ako nabutang diri, no, but it's actually 60 to 70%. Okay? So, kani 60 to 70% of our energy expenditure comes from basal metabolism. So, components, okay. Mao ni ang mga certain definitions sa mga terms that are related with basal metabolism. So, basal energy expenditure or BEE, this is the amount of energy used in 24 hours by a person at complete rest, lying down in a comfortable environment and temperature, and 12 hours after the last meal. Basal metabolic rate, BEE, as expressed per kilogram of body weight per hour. Okay. So, kaning BEE, mao na siya ang amount of energy nga atong gina-spend when we are just at complete rest, when we are lying down in a very comfortable environment and temperature, and mao ni siyang fasting no nga state 12 hours after the last meal. So basically kanang gatulog ta, it's part of our BEE kay naabot tay energy. Gaspen pagyapon tag energy bisag ga-rest ta. Yes, natay basal energy expenditure because our heart is continuously operating. Our na mga brain activities nga it would not cease to operate. Our breathing process, lisod pod kundi ta mag ginhawa while gatulog, mamatay ta. Okay? So it needs basal energy. Okay? So that's a part of the basal energy expenditure. And kaning basal metabolic rate, it's just the BEE, then na siya unit, no, expressed as per kilogram of body weight per hour. Then what is this resting energy expenditure? This is the amount of energy used in 24 hours by a person at rest and 3 to 4 hours after a meal. So, kani siya as mas dako ni siya, no, i-compare sa BEE. Kay kani 3 to 4 hours after a meal lang, then kani is 12 hours after the last meal. Pero they are both at rest. Pero ang difference lang is ang time nga gikan, the time gikan nga nag-consume ang taog meal. The REE includes some energy expended for digestion and absorption, which is about 10% higher than the BEE. So therefore, your REE is 10% higher than BEE. Then your resting metabolic rate it's just the rate of the REE. So REE expressed per kilogram of body weight per hour. Okay? So do not confuse BEE with REE because they are different. The difference is that REE is higher than BEE because of the shorter period from the time the last meal is eaten. Okay. Factors affecting basal metabolism. So we have body size, body composition, age, sex, hormonal status, environmental temperature, presence of pathologies, and presence of malnutrition. So body size. Okay, kung mas dako ang body proportion, mas dako ang basal metabolism. Okay? So therefore, the rate of our BMR actually differs from one person to another. Although generally mag-fall siya between 60 to 70% of the TR. Body composition. So di ba lahi man ang babae sa lalaki when it comes to body composition? Why? The difference is that the body fat, the proportions of body fat and body muscles. So mas dako ang body muscles sa lalaki kaysa sa babae. And body muscles are more metabolically active than body fats. Okay? So that's why mas dako ang basal metabolism sa lalaki kay mas dako man siya og proportion sa muscles, and muscles are more metabolically active than fat. Age. As we age, as our age increases, our basal metabolism decreases. So that's why mas dako ang basal metabolism sa younger than the older. Mao pod ang ga-contribute no sa fat deposition as the person ages, kay mas daghan nga ma-accumulate nga fat ang kanang kuan, ang mga tigulang, kay while gakatigulang sila no gakagamay man ang metabolism, ang metabolic rate. So that's why more energy is stored than expended. So that explains nga nung mas daghan og fat accumulation as the person ages. Sex, okay, I have already explained, mas metabolically active ang lalaki due to the higher proportion of body muscles. Hormonal status, testosterone and estrogen are actually kanang kung ano, anabolic ni sila nga mga hormones. So related yapon siya sa sex, no, since ang testosterone is more on muscle building, so that's why it would put the male into a state of higher basal metabolism. Okay, kay kaning testosterone man good into muscle building siya, so therefore mas taas gyud og basal metabolism ang mga lalaki because testosterone is the male hormone. Environmental temperatures, okay, mas metabolically active ta kung init because it's heat, di ba? Init. So that would actually increase the basal metabolism of the body. Kung cold, it would decrease the basal metabolism of the person. So kung winter, pero we do not experience winter but in certain areas of the world nga kaka-experience of 4 seasons. So during winter mas gamay ang rate of metabolism during winter. Okay? Diri sa ato kay rainy o dry seasons naman diri sa ato, then bisag rainy kay naaya pon mga time nga init. So yeah. Bali ko ano rin no, constant ang ato ang BMR as influenced by the environmental temperature. Presence of pathologies, kung pathologies means sakit or disease, so presence of disease, kung naatay sakit, no, mas mutaas atong BMR, specifically kung chronic disease like cancer, COPD, okay, yeah, and mga inflammatory disorders, so mas taas ang basal metabolism. Presence of malnutrition, kung naay malnutrition ang individual, mugamay actually ang basal metabolism. Like for example, obese individuals, they are malnourished because they are overnourished. So, mas gamay ang BMR sa mga obese. Okay? What about mga undernourished? So, kaning mga undernourished na to, they are actually mas gamay po na ilang basal metabolism. So, both undernutrition and overnutrition would make the person have lower BMR than the normally nourished individuals. Okay. So, measures of basal metabolism. So, how do we measure, guys, ang basal metabolism? So, through indirect calorimetry. So, katong akong gipakita, no, katong mga whole room respirometer or respiration chamber. So we measure the amount of carbon dioxide released para makorelate na to siya sa amount of energy expended. Use of the RQ, okay, then calorimeters and doubly labeled water. So this is actually a type of apparatus no used or a technique used para ma-correlate na tong amount of water expended, actually ang hydrogen, ang H2 nga deuterium, so this is an isotope of hydrogen, no? And kanisad oxygen 18, because actually the normal water is oxygen 16 and oxygen hydrogen 1 mao na mga isotopes, no? Kani mas daghan siya neutrons, so that's why nahimong 18. Yeah, but bisag dili sila normal no nga water, pwede gyapon nato magamit as kanang normal nga body water. So and the tendency man good is that if mao ni atong gamiton, then kanang kung unsay mahimo nato nga water kay mo reflect ang may baw-an nato katong mga dili normal nga hydrogen ug dili normal nga oxygen katong mga isotopes. So it is then correlated to the amount of energy expended. Okay, kay sa in some ways ma-measure nato ang amount of energy by measuring the amount of isotope hydrogen and oxygen lost, okay, after metabolism. So that's doubly labeled water. So the use of radioactive hydrogen and oxygen. These are the respiratory quotients of some substances. So we have, okay, so katong gipakita na ko last time. So remember that fats have just 0.7 RQ. Then kaning mga organic acids na to, no, malic acid, tartaric acid, and oxalic acid have higher RQs. Okay. We can of course use the different formula mao ni atong ginagamit. And I don't know if naka-laboratory na mo ani sa mga HE54 students, but yeah, this would be familiar to you, kaning Harris-Benedict formula. So mao ni atong ginagamit para i-measure ang BEE or basal metabolism. Okay? The Harris-Benedict formula. So this does not measure the whole TER because the TER is not just the BMR but also physical activity and TEF. Another way to measure the BMR is this one, 1 calories per kilogram of IBW for males and 0.9 calories per kilogram of IBW for females. Sorry, for females ni siya. Ko ang i-edit. Okay. Sige. Wait, pila na ta? Okay, it's been an hour na gyud ay. Okay. Okay, so mas gamay ang basal metabolism sa babae. That's just 0.9 calories per kilogram of IBW. So you recall guys that you have to compute for the IBW para ma-derive niyo ang amount of calories required for basal metabolism. So the second component of energy expenditure is PA or physical activity. So it's second largest component. So 10% of the TER for the bedridden. So katong mga patients no nga gahigda IRA, and then 50% to an athlete's TER or katong mga physically active. So up to 50% ang of their energy is expended for physical activity. So all physical movements and activities beyond the basal kay component siya sa physical activity. So use of a table. So how do we measure the physical activity? Pwede mag-use tag table, no, just like this. So for example, bed making, it would require 3 calories of energy per kilogram per hour. Okay? Boxing, that's a very physical nga work. So that would mean higher energy requirement or higher energy expenditure. So actually 11.4 calories per kilogram per hour. Dancing, 3 calories per gram. At 3 calories per kilogram per hour. Asa man diri ang walking. Kaning normal walking, 3 miles per hour, it's just 2 calories per kilogram per hour. So say for example, sige, ato ni siya ikuan ha, i-compute. Kaning mag-walk ka, okay? Wait. Asa itong akong calculator. Okay. So, for example ha, naglakaw kag, saan ni? Ay, tura di ay ba? 1, 2, 3, 4, 5. Oh, yeah. 2 calories per kilogram per hour. Say for example, ang imong weight is 60 kilograms and then naglakaw kag kanang 3 hours. 3 hours ka naglakaw kay I don't know, basta nag-exercise or something or okay, let's just say nga nag-walk ka for 3 hours then 3 miles per hour na siya. So since you weigh 60 kilograms, so that's kuan man 2 calories per kilogram per hour. So that's 2 times 60 because imong weight is 60, then 3 hours. So 360. So pila lang ka calories ang imuhang na spend by walking for 3 hours. And if you weigh 60 kilograms, that's only 360. 360 calories. So that's very small, 'di ba? Pila man ang 360 calories? One cup of rice is 200. Okay, so that's just like around 2 cups of rice. Okay. So, para ma-burn mo ang 2 cups of rice, you have to walk for 3 hours. Yeah, imagine, 'di ba? So, mao na lagi nga grabe gyud ang makuha nato nga energy no by eating rice. Kay imagine 2 cups of rice para ma-burn na siya, kinahanglan ta mag-walk og 3 hours. Okay. So, yeah, so I hope you find this table very interesting. So you can actually kanang kuan measure your own energy expenditure by using this table. So this table is called energy cost of activities. Okay. We can use that as a part of formulae. So I don't know if gihatag na ni sa inyo hang kuan. Wait ha, nasa ganito. Okay, ni. Of course, the ND51 students, kabalo na ni sila kay nagamit naman ni nila nga mga sa laboratory activity ni sa kuan sa nutrition fundamentals actually. Okay. Wait lang, lag siya. Okay. So, exercise number 6 siya actually estimating energy requirements. So, katong TR, natay tulo ka components, B, E, P, A, and T, F. So, kani siya nga slide no, it would show you unsaon pag kuha sa physical activity through the use of different formulae. So naatay factorial method. So para makuha na to ang TR. So mao na ang kinahanglan nimo nga energy per day. So ang BMR i-times nimo sa physical activity times stress or injury factor. So yeah. So the Harris-Benedict formula mao ni. Okay. Then mao ni ang mga different tables, no? So para lugar makuha nato ang TR nato, no? So i-times nato ang na-derive nato nga BMR diri sa Harris-Benedict formula times nato sa physical activity. So tanawon nato diri. So if you have sedentary lifestyle, then times nimo na sa 1.3. Then after that naa na kay TR nimo. Okay? That's the long method. Apil pud ani, no? Cross and Mahan method. But sa quick methods, dali ra. After you get your ideal body weight, i-times ra nimo kung unsa imong activity level. Say for example, kung naalang kay light activity, usually ang mga students like you na light activity. But this is pre-COVID. Karon kay online class man ta, so siguro very light activity lang or even bed rest. Ay dili sa bed rest, oy grabe. Wala lugar mo ga trabaho di sa inyong balay, okay? So very light activity in your case. So the IBWC, for example, by using different formulas, diba magamit ng different formulas para makaderive tag IBW, i-times na nimo sa kung unsa ang imong activity level. So if it's very light activity, so for example 50 mong IBW, so 50 times 30, so pila na 50 times 30, 50 times 30, so that's 1.5. So therefore 1.5 imong TR kay very light raman imong activity. But for example, you are physically active, ga-gym ka, okay, then 50 imong IBW, so 50 times 45, so that's 2,250. Pila nga increase, na-increase siya from 1.5, okay, kung ang imong activity is high. Yeah, so mauna siyang pasabot aning use of as part of the formula. So naasa diri, no? So if you are a teacher, nurse, student, lab technician, housewife with maids, light imong activity level. Okay, for males 40, females 35. Okay, so you know this already. I hope sa mga HA54 students nakaabot na mo ani. Okay, the last component of energy expenditure is thermogenic effect of food. To arawa pa pud na ako na edit, no? So ako i-edit TAF. So the TF, so this is the increase in energy expenditure brought about by the consumption of food. So tungod ni siya sa mga effects sa mga chemicals na makita nato sa foods. So typically 8 to 10% of our TR is due to thermogenic effect of food. So 8% for a Filipino diet. So magdepend siya kung unsa nga diet, no? For Thai, ang contribution sa TF nila sa ilahang energy expenditure is 33%. Very high tungod sa ilang spicy foods. Kaya grabe man gud na maka-induce og kainit, di ba? Ang spicy foods. So that's why it would somehow be a part of their energy expenditure. So that's why 33% ang TF sa mga Thai. And other cultures nga very spicy ilahang foods. Then up to 16% for coffee and tea drinkers and for smokers, because kaning caffeine and nicotine naapod sila stimulating effect, no? So that's why 16% ang TF sa mga inani nga mga consumers. Determination of energy requirements or determination of TR. So, pwede ta magamit og PDRI or formula. So, kung magamit tag formula, mao ni atong gamiton. I hope na mo'y copy. Murag ang mga HEF 54 students nakapalit naman sila katong libro sa IMDC. Naara ni. Pero kung gusto nimo shortcut, Pero mas nindot no magamit og formula kay individualized siya. Kani man good PDRI for the general population, but we can still use it. Pero mas preferred kung magamit og formula. But in order to just show you sa akong paggamit sa PDRI, and of course, you know this already. Kung lang ipakita outro. So, I hope po na may copy sa PDRI. Okay, so kani so REI, energy recommended energy intake. So you just match your age sa imuhang sex, and then you would then know kung pila ka calories. So for 19 to 29 years old nga lalaki, 530 calories per day. Okay, so that's how we use the PDRI for the determination of the TR. Okay. Food balance sheets. Okay. So, kaning food balance sheets, they show a brief picture of the pattern of the food supply of a country. So, for each food item, it sketches the primary commodity availability for human consumption, so the sources of supply and its utilization in terms of nutrient value. Okay, let me just open my kuan ha. Na ako tab nga gina-open man good for. Oh, wait. Na makita ninyo ako ang kuan. Okay, kani. Okay. So kaning food balance sheets, they basically give us the amount of energy, amount of calories available for wait, ngano wala man kailangan na ako yung na-remember nga wala siya na-appeal. Wala. Okay, sige. Sige, so nganong calories man atong ginagamit? Okay, mao day ni ako nakaligtaan no. Nganong calories man ang atong ginagamit diri? Yeah, that's how we express the value of energy in our foods. So in the form of calories. Napay isa, that's kilojoules. So para i-convert nimo ang calories to kilojoules, so you just have to multiply the amount of calories by 4.184. Again, multiply the amount of calories by 4.184, and you would know the kilojoules. And kilojoules is actually the SI unit for food energy. Dili actually calories. But nganong calories man ang gina-use kay mauna man na ang traditional, then most consumers associate energy from foods in the form of kilocalories or calories. Okay. Naapod zero confusion as to unsaon gyud nato pag-pronounce aning kcal. Okay? Ang pag-pronounce na actually it's just calories. Okay, you don't have to say it nga kcal or kilocalories. Calories is enough. So when you say calories, automatically pasabot ana is kcal. Okay? So don't read it as 4 kilocalories. No, 4 calories is okay na. Okay? So yeah. Okay? Mura na akong nalimtan actually. Na ato'y slide for that, but nganong nawala siya. Tingala ko. Okay, let's go back to food balance sheets. So, food balance sheets, kibali, mauni, a brief picture of the pattern of the food supply of a country. So a food balance sheet is a comprehensive compilation of a selected country's food supply during a specific time period. So the food balance sheet shows the food items for human consumption along with how it is produced, used, imported, exported, and how it benefits the society per capita of supply. So ang ga maintain aning food balance sheets no kay ang Food and Agriculture Organization. So in every country guys kay makompute nila ang ang energy or ang calories nga available for human consumption per capita. So kani siya actually. Pero this is from 2006 to 2008. Outdated na nga data no. So United States has the most available food energy per individual. So 3,800 calories ang available no sa kada American. Okay? This is very high. So there is no doubt nga nung grabe pud ang rates of obesity dito sa ilaha kay dako kayo ning 3.8 uy. Tapos ang kinahanglan lang nila is actually around 2.5. Okay. Asa ka ang Philippines diri? Philippines. Nara. Nata sa ikaw 105th. So 2,580 calories ang available per individual per Filipino. So it's okay. Okay ra siya, dili sad pud siya deficient pud. Then mga around diri pud ang kinahanglan nato na average. So that's what the food balance sheets tell us. So kung gusto niyo updated nga version then you just go to the food balance sheet sa FAO. Wala lagi diri ba? Okay. Yeah, but kaning food balance sheets pod wala ni gina-include ang food wastage in the household level. So dili pa sabot nga kaning 3.8 mao gyud ni ang ginakaon, gina-use sa every person in the United States because the food losses in the household levels are not accounted. So katong mga plate waste or katong mga amount of foods fed to the pets, they are not included in the computation of the dietary energy per capita. Per capita means per person. Let me open the one food balance sheet that I have downloaded. Updated siya actually no. Saan na to? Sige, atong i-extract. Okay. Yeah, for example, in Afghanistan, ang food supply per capita is 2019 calories, 1978 calories, 2001 calories, 2000 calories. Okay? In the year 2017. Kaya ang pinaka-updated nila is actually 2017. So let's check for the Philippines. Sa Philippines diri. Gi-download na ko ni sa FAO nga website. So actually kani ma-encounter ninyo ni sa community nutrition ninyo nga subject, but ako na lang ta mo introduce daan because it's related with energy. Philippines. Okay. As in taas kayo ni nga spreadsheet, guys. Wait. Okay na lang. So, pila to ang food supply per capita? Yeah, 2,564 katong 2017 latest 2,674 calories. So, mao ni ang available sa kada Filipino per day. 2,674 calories. So, dili ra ta deficit, dili ra ta food insecure, oy. Kay this is okay. Okay ni siya nga energy available for us. Okay? Pero dili appeal ha ang wala diri na account katong mga food waste sa household na nga level. Kay dili ni siya pasabot nga 2,674 yun atong nakuha in every person in the year 2017. Kay napa may mga food loss like kanang dili na to mahurot, then kaon na to sa kuan sa itong mga pets. Okay, so dili included sa food balance sheets. So yeah, but unsay kanang kuan appeal sa food balance sheets then. The food balance sheet shows the food items for human consumption along with how it is produced, used, imported, exported, and how it benefits the society per capita supply. What about energy nga as a result sa National Nutrition Survey? So kaning NNS sa inyohan pud ni nga community nutrition, no? And the latest survey, which is in 2018, ang amount of calories nga gi-consume nato, actually kani gi-consume gyud siya. Unlike food balance sheet nga supply, kani gi-consume gyud. So we can really say nga mao ni ang na-consume nato on an average, ha. So on an average, that's 1,774 per person per day in the year 2018. Pero ga-decrease siya. Ang pinakamubo no nga energy intake na to kay katong 1993. Okay. Then ang pinakataas katong year 2003. Diri siguro nag-boom atong economy, so that's why taas ang atong energy intake, because the energy intake would also somehow reflect the level of economy because it's related with the food production and food supply. Okay. So, asa na ninyo nga website makuha ang mga results sa National Nutrition Survey? Diri sa innutrition.fnri.dosd.gov.ph. The result of the different National Nutrition Surveys. Okay. So, let's proceed to energy balance and imbalance. So, energy balance is basically the amount of energy in and the amount of energy out. So mao dapat ni ang ato ang strive for, dapat equal ang ginapasulod na to sa ginapagawas na to nga energy. What would happen kung naay imbalance? Okay? So of course naay mga consequences. Okay? So kani kung mas dako ang energy in kaysa sa energy out, so weight gain. Kung mas dako ang expenditure, ang energy out kaysa sa intake, then weight loss. So mao ni dapat para ma-maintain nato atong weight. So ang intake is equal to expenditure. So energy balance. Dili imbalance. Parehas aning duha. Okay, so energy intake is actually measured through this. So, ma-encounter ni ninyo sa inyong nutrition assessment. And I hope nakagawas ay nakaabot na mo ani. Energy expenditure is measured katong gi-discuss na ko last time. Katong mga calorimetry and the doubly labeled water, of course. To put that in an equation, so energy intake from foods is equal to energy expended, energy expenditure, plus change in stored energy. So, changes in the body fats and glycogen storage. So, mao ni ang energy balance. So, at both sides of the equation, dapat equal para walay mga negative consequences. Okay, positive energy balance so leads to overweightness and obesity. So, results from overeating and sedentary lifestyle. So, kaning sedentary lifestyle, no, mao ni siya ang wala gi-emphasize kaayo. Kay, actually, contribute yun kaayo ni siya sa obesity. Dili lang nga mag-overeat ta, no, tungod pud kay wala tay physical activity. So, wala gyud expenditure. So, that's why, mao yun ni ang mahitabo, guys. Daghan kayo ang na-store pero walay nagkakagawas nga energy, walay nagkaka-burn nga mga calories. So, weight gain yun. Okay? And grabe ning obesity, no? If a person is obese, taas yun yung risk of developing many diseases. DM, hypertension, cancer, neurodegenerative disease like Alzheimer's, Parkinson's disease, gastrointestinal disorders, liver, pancreatic disorders. Actually, halos tanan nga mga kuano, nga mga diseases that are very important nowadays kay ang risk factor yun is obesity. So that's why the field of nutrition is very important in order to solve the obesity problem, because obesity is actually the single most the single factor that has the most impact on many diseases. Okay, so mao na atong role, so that's why dako ang role sa mga dietitians in order to intervene obesity. At the other side of the spectrum, negative energy balance, so complete opposite sa positive energy balance, no? So it leads to underweightness and PEM, so undernutrition na sad ni. So results from inadequate energy intake, starvation, fasting, anorexia, digestive disorders, hypermetabolism due to injuries or chronic disease. Okay? So unsa dapat atong strive for? Kaning energy balance lang, not positive or negative. Okay, on other topics, energy homeostasis, fasting, and circadian rhythm. Okay, I will first discuss kaning energy homeostasis. Kay kaning fasting and circadian rhythm, most of these, I will leave this for your own reading. Kaya na ako ipasa nga mga websites for you to read. Okay, pero maghatag ya po a little bit introduction para mag-guide mo sa pagbasa aning mga topics. Okay? Sige, let's first discuss kaning energy sa to, energy homeostasis. Okay. Energy homeostasis. So this is kani siya nga topic, no, kay diri magsulod ang hormonal control. Okay? So, the involvement of hormones in the energy balance. So, dili ra inato kadali, no, nga dapat mag-less imong kaon, then more imong physical activity para dili ka manambok. Actually, naapay mga factors nga dapat i-consider. So, one of that is hormonal control. Okay? So, the body is a continual state of hunger which is intermittently relieved by eating. So, this perpetual drive to eat is periodically suppressed by inhibitory impulses generated by such things as the presence of food in the GI tract, the flow of nutrients into blood, and other factors. So, after these satiety factors have dissipated, the desire to eat returns. Obesity is the most prevalent nutritional diseases of the human race and bisag pa in other members of the animal kingdom. exceeding by far the number of nutritional deficiency diseases. So that is also, I told you, no, that obesity is the single risk factor that has the most impact on the pathophysiology of many diseases. Okay. So actually, naatay ka ng kung ano, hunger center sa atong brain. So this is actually the part of our brain that senses hunger and satiety, and that is the hypothalamus. So such studies clearly identified two regions in the hypothalamus that dramatically influence feeding behavior. Lateral hypothalamus is the hunger center, so this is the one that stimulates hunger, and then the other part of the hypothalamus that senses the satiety. Satiety is ang pagkabusog, di ba? The ventromedial hypothalamic nucleus. Okay? So, yeah, lateral hypothalamus, animals with lesions in this area become anorectic and lose weight. Ventromedial hypothalamus, animals with lesions in the area overeat and become obese. So, nganong na-identify man nila nga mga regions, it's because kung naay mga defects aning nga area, it can lead to anorexia and negative energy balance. So that's why this is the hunger center. Mahimo da yung obese, no, kung naa kay defect aning nga area sa ventromedial hypothalamus. So that's why this is considered the satiety center. Okay. So how is how are these centers stimulated? Okay, due to many factors. Okay, first is the appearance of food. So just the mere appearance of food can make us hungry, di ba? So therefore the lateral hypothalamus is stimulated para mahimutang hungry, no, for that food. Taste and or odor of food. Okay? Learned preference and aversion. So kung naatay mga food aversions, that would actually suppress our hunger center. Okay. What about the involvement of hormones? Okay. Ghrelin. Ghrelin is a hormone that is produced by the stomach and it stimulates the appetite. So that's why it stimulates the hunger center and it suppresses the satiety center. So kung magutom ka, ghrelin is actually accumulated. So mag-accumulate ang ghrelin, dayon ka, no, kanang gutomon dayon ka, because one of the hormones that does that is ghrelin. Cholecystokinin is the opposite. It is actually the hormone that causes satiety. So kung busog na ka, it's actually being signaled by the cholecystokinin. Okay. Another is the influence of insulin and glucagon. So insulin actually induces satiety and suppresses hunger. Ang glucagon is the opposite. It suppresses hunger. It induces hunger and suppresses satiety. Okay. The set weight or the set weight theory. So sa maning set weight theory. This explains kanang some people find it hard to lose weight kay kung i-reduce man gud nato ang atong calorie intake, grabe ang temptation, no, to eat. It's because mas mutaas si ghrelin concentration. Okay? So yeah, If an animal is starved for a long period of time, then allowed access to food, it eats a far greater amount of food than a normal animal. Conversely, if an animal is force-fed for several weeks, then allowed access to free choice food, it will not eat very much. So in both cases, when weight returns to set weight, feeding behavior normalizes. So set weight is, kibali mauna na imong timbang nga gina-recognize sa imong body. So mauna siya ang gina-strive yun sa imong body nga dapat mo balik ka na nga weight niyo because that's your set weight. Siguro mauna inyong ma-observe na siguro yung mga set weight. Say for example, ako kay naagid ko 65 kilograms nga set weight. Like for example, dili ko magkaon or unsa, I will then tend to overeat para siguro dili ko mo mubo sa akong set weight. Then kung mag-overeat ko due to abundance of foods, the body would strive nga dapat dili siya mo exceed sa 65. So that's actually the concept of set weight. So an additional interesting observation is that when food is restricted, basal metabolic rate decreases, which is one reason that it is so difficult to lose weight by dieting. Yeah. Diba katong ingon nako if food is restricted, mugamay ang BMR. So that's why mas lisod pag yun mag-lose og weight kay nigamay ang imuhang basal metabolism. Okay, so naay other hormones no that also affect food intake like leptin. So leptin is synthesized and secreted predominantly by fat cells. So leptin actually suppresses hunger and promotes satiety. Okay? So for example, if puno na ang fat cells by fat because they store fat, that's their main function. Kung puno na ang fat cells sa fat, mag-release dayon ng fat cell og leptin. Then i-receive na siya sa brain, i-receive na siya sa hypothalamus, and then unsa may himuon ni hypothalamus dayon? Masuppress ang hunger, then ma-promote ang pagkabusog or satiety. Because that's the way of the fat cells to tell your body nga, uy, sakto na. Sakto na imong kaon kay puno na kog fat. So that's why mag-release siya leptin para ma-suppress ang hunger, then ma-stimulate ang satiety or ang pagkabusog. So that's why plasma levels of leptin rise and fall in parallel with body fat content. So as body fat increases, so does the concentration of leptin in the blood. Okay. So, mauni siya ang the energy homeostasis or the effect of some biological components of our body to the food intake and body weight. For fasting and circadian rhythm, na ako ipabasa sa inyo kani for the circadian rhythm and kaning duha para sa intermittent fasting. So siguro curious mo nun sa man yun ng intermittent fasting and unsa pud ning circadian rhythm, unsa influence niya sa energy homeostasis. So ihatag na ko din siya nga website nga mga websites sa Google Classroom together with this video. And then we will have an open forum of this sa Tuesday. Okay? So since pila na ni ka minutes, okay, 1 hour and 43 minutes. Okay, it's almost 2 hours. So I have to end this video already. Okay? So let's just see you on Tuesday para sa open forum. Okay, so read this ha para kung naamoy mga questions, then I will answer your questions sa Tuesday. Okay, thank you everyone for listening.